Every great shelter starts with a simple idea, but turning that idea into a structure capable of standing against cold, moisture, and time requires careful planning, patience, and precision. In this project, we'll follow the complete construction of a warm underground bunker built almost entirely by hand, using modern building techniques designed for durability and year-round comfort. Before a single block is laid, the first challenge is preparing the construction site. The ground has already been excavated, leaving a deep rectangular pit that will eventually become the bunker's foundation. The walls of the excavation are carefully shaped to provide enough working space while keeping the surrounding soil stable. Working below ground level always comes with risks. Loose soil can collapse unexpectedly, groundwater can create drainage problems, and even small measurement errors become much larger once construction begins. That's why every successful underground project begins with accurate preparation instead of rushing into building. With the excavation complete, attention shifts to creating a solid base. The bottom of the pit has already been compacted to reduce future settlement. A level foundation is one of the most important parts of any structure because every wall, every corner, and every roof section depends on this surface remaining perfectly stable for years to come. Now, heavy machinery enters the site. Instead of transporting every load manually, a compact loader moves materials directly into the excavation. This saves enormous amounts of labor while allowing construction to continue much more efficiently. The next delivery consists of large white construction blocks. These aren't ordinary concrete blocks. They're lightweight, aerated concrete blocks known for their excellent thermal insulation, fire resistance, and dimensional accuracy. Their precise manufacturing makes them ideal for creating straight walls with thin mortar joints, reducing heat loss through the structure. Before laying the first block, the builder carefully checks every measurement once again. Corners are verified, reference lines are established, the layout is confirmed. At this stage, correcting a mistake only takes minutes. Later, it could require rebuilding an entire wall. The first mortar is mixed carefully. Unlike traditional thick cement beds, this specialized adhesive mortar creates a very thin bonding layer between the blocks. Thin joints not only improve insulation, but also ensure the finished walls remain perfectly level. The very first corner block is placed slowly. This single block becomes the reference point for everything that follows. Its height, its alignment, and its position determine the accuracy of the entire bunker. Using a long spirit level, every side is checked repeatedly. Small adjustments are made with gentle taps until the block sits perfectly flat. Only then does construction begin. One by one, additional corner blocks are installed. One is a not only with a weight, but also with a surrounding area.
One careless placement could affect every course built above it. Another interesting detail is how the builder frequently changes viewing angles while checking alignment. Looking across the wall from different perspectives makes even slight deviations much easier to detect than relying on instruments alone. Experience often complements precision tools. By now, several complete courses surround the excavation. The clean white blocks contrast sharply against the dark soil, making the growing bunker stand out clearly within the construction site. Despite the simplicity of the materials, the structure already conveys a sense of permanence. Every completed row represents another step toward creating a secure underground refuge designed to withstand harsh weather for many years. As construction continues, future openings begin taking shape. Certain wall sections remain carefully measured to accommodate entrances and structural transitions that will appear later in the project. Nothing is left to guesswork. Every dimension has already been planned long before construction began. With each passing hour, the bunker grows stronger. The foundation supports the walls. The walls define the space. And every carefully placed block brings the project one step closer to becoming a fully enclosed underground shelter. But the most demanding phases are still ahead. Higher walls, structural reinforcement, waterproofing, and eventually a roof capable of supporting the enormous weight of soil above. For now, though, the focus remains exactly where it should be, building an accurate, level, and exceptionally strong foundation for everything that follows. With the foundation established and the first courses of masonry completed, the bunker has officially entered its next stage. Every additional row of blocks brings the structure closer to becoming a permanent underground shelter. At this point, patience remains just as important as strength. Precision is still the builder's highest priority. As construction resumes, fresh adhesive mortar is spread evenly across the top of the previous course. Instead of applying thick layers, only a thin, consistent bed is needed. This specialized adhesive creates an incredibly strong bond while maintaining excellent thermal performance. Each block is lowered carefully into position. A slight sliding motion helps distribute the adhesive evenly beneath the surface, ensuring full contact between the two blocks. Once positioned, the builder immediately checks both horizontal and vertical alignment. Even though the wall already appears straight to the eye, construction tolerances at this point are measured in only a few millimeters. Every correction made now prevents much larger problems later. The walls continue rising steadily around the perimeter of the bunker. With every completed course, the excavation begins to feel less like a construction pit and more like an actual underground room. The interior dimensions become easier to appreciate, revealing a surprisingly spacious environment hidden beneath the surface. One remarkable advantage of aerated concrete blocks becomes incredibly obvious. Despite their large size, they remain relatively lightweight compared to traditional concrete masonry units. This allows construction to move faster while reducing physical strain on the builder. At the same time, these blocks provide impressive insulation properties. Tiny air pockets trapped throughout the material help reduce heat transfer, making the bunker naturally warmer during winter and cooler throughout the summer months. For an underground shelter where maintaining stable temperatures is essential, this material offers significant benefits. As work progresses, occasional adjustments become necessary. Not every block fits perfectly without modification. Certain sections require custom cuts to maintain clean corners or prepare future structural openings. Using a specialized masonry saw, the builder trims individual blocks with remarkable accuracy. The freshly cut surfaces remain clean and square, allowing them to bond just as effectively as factory edges. Rather than rushing, every custom piece is dry-fitted before adhesive is applied. This extra step ensures perfect placement while minimizing waste. Soon, another complete course is finished. Again, the long spirit level is placed across multiple blocks. The builder studies every reading carefully. No shortcuts, no assumptions. Just consistent verification after every stage. This attention to detail may seem repetitive, but it's one of the defining characteristics of professional masonry. As the walls climb higher, structural stability naturally improves. Each overlapping course distributes weight evenly throughout the entire perimeter, creating a solid shell capable of supporting tremendous loads. Eventually, this bunker will not only support its own roof, but also thousands of kilograms of compacted earth resting above it. That future load makes today's careful craftsmanship absolutely essential. Construction continues from one corner to the next. The rhythmic pattern has become almost meditative. Spread adhesive, position the block. Tap
gently into alignment, check level, move forward. Hour after hour, the bunker grows stronger. Now the builder begins preparing important structural details. Specific locations are measured repeatedly before additional blocks are installed. These sections will eventually support heavier components placed later in the construction process. Accurate measurements today ensure those future installations fit perfectly without unnecessary modification. Inside the bunker, the walls have reached nearly chest height. Walking through the structure now provides a clear understanding of the finished layout. The enclosed space already feels protected from the outside world. Surrounded by thick masonry and earth, it's easy to imagine how quiet and insulated this bunker will eventually become.
Underground construction has always fascinated engineers because the surrounding soil naturally protects against strong winds, extreme temperatures, and even external noise. When properly waterproofed and ventilated, underground structures can remain comfortable throughout every season. However, moisture remains the greatest long-term challenge. Rainwater naturally moves through soil. Without careful planning, hydrostatic pressure can force water against underground walls year after year. That's why modern bunker construction depends on multiple layers of protection, rather than relying on masonry alone. Although waterproofing materials may not yet be visible, every step being completed now is preparing the structure for those future protective systems. As the walls continue upward, another important construction technique becomes noticeable. The builder constantly alternates working positions around the perimeter. Instead of concentrating on one section alone, each wall rises at approximately the same pace. This balanced approach helps maintain uniform loading while keeping all corners aligned throughout construction. It's a small detail, but one that contributes significantly to the finished accuracy of the building. Meanwhile, sunlight gradually shifts across the construction site. Hours have passed, yet the steady pace never changes. Professional builders understand that consistency produces better results than speed. Every completed course represents permanent progress. Unlike temporary scaffolding or excavation work, these walls are becoming part of a structure designed to last for decades. Occasionally, excess adhesive squeezes from between the joints. Rather than leaving it in place, the builder removes it immediately with a trowel. Clean joints not only improve appearance, but also create a smoother surface for future waterproof coatings. Preparation today saves considerable effort later. As another layer is completed, measurements are checked once again. Diagonal dimensions confirm that the bunker remains perfectly square. Corners remain true. Walls remain parallel. Every successful structure depends upon this level of geometric accuracy. Now, attention begins shifting toward the upper sections of the walls. The finished height is approaching. Soon the structure will be ready for one of the most demanding stages of the entire project, the installation of the roof system. Unlike conventional buildings, an underground bunker roof must perform two very different functions simultaneously. First, it acts as a ceiling for the interior space. Second, it becomes a retaining structure capable of supporting massive loads from soil, vegetation, snow, and occasional maintenance traffic above. That combination demands exceptional strength. Before reaching that stage, however, the wall tops must remain perfectly level. Even slight variations could complicate roof installation significantly. The builder continues checking elevations from multiple directions. Tiny adjustments ensure every wall reaches exactly the same height. Looking around the excavation now, it's remarkable how dramatically the project has transformed. Only hours earlier, this was an empty hole in the ground. Now, solid, insulated walls define a permanent underground shelter, taking shape one block at a time. The clean white masonry stands in sharp contrast against the surrounding earth,
highlighting the precision of the construction. Despite being buried below the landscape, the bunker already conveys a feeling of permanence and security. The remaining work will only strengthen that impression. Soon, preparations begin for structural reinforcement. Additional materials arrive at the site. Each delivery represents another important milestone in the build. Heavy components that once seemed unnecessary now become essential as construction advances toward enclosure. Every successful underground shelter depends on teamwork between different building systems. The masonry provides insulation. The reinforcement supplies strength. Waterproofing prevents moisture intrusion. Drainage protects the exterior. Finally, proper ventilation ensures the interior remains safe and comfortable for long-term use. None of these elements can succeed alone. Together, they create a structure capable of enduring decades beneath the surface. As the final blocks of the stage are installed, the bunker walls now stand at nearly their full intended height. The overall form of the site is complete. Only the structural cross-section remains before attention shifts toward unfolding the state's plan. Standing inside the bunker now feels completely different than it did at the beginning of the project. Instead of standing inside an excavation, you're standing inside a legal breach. The walls surround you with thick, insulated masonry. Natural light still enters from above, but that will soon change. Before long, the roof will seal the structure, transforming it into a protected underground environment designed to withstand both close entry and tropical heat. The most technically demanding chapter of the build is about to begin. The walls have done their job. After countless hours of careful masonry work, the bunker has reached one of the most significant milestones in the entire project. The walls now stand at their full height, creating a solid underground base ready to support the new structure. But here's where the trick begins: the refuge. Unlike a conventional building, an underground bunker doesn't simply need a roof to keep out the heat. It's made up of a structural barrier capable of carrying unlimited pressure. Once construction is complete, pressure expands its shell will rush directly out, allowing moisture, vegetation, hidden materials, and a constant pressure to surround the area. That means every component installed directly above the structure absorbs one continuous pressure efficiently. The builder begins preparing the upper edges of the site, carefully sealing the base inside the walls and ensuring every surface is perfectly level. Even the smallest irregular shifting, uneven loading makes the roof exposed. Accuracy remains just as important now as it was when the build first began. Every structural element is carefully positioned in place. Unlike the lightweight masonry almost used for the walls, these components are designed specifically to resist bending forces and transfer rapidly and safely across various surfaces. Each piece is laid slowly, precisely, and adjusted in place so it can quietly support the structure. There is no room for error. Once the roof supports are aligned, the bunker finally begins to transform, transitioning from structure site into a completely enclosed underground area. But here you'll find changes immediately. For the first time, the site starts to reveal new layers inside an excavation pit. Natural light enters insulated walls. The pit walls surround the interior. This is a period not of orders and underground life, but of structurally strong belows never imagined underground construction. Now comes one of the most important phases of the excavation process: the excavation. Water is incredibly fragile. Given enough time, even the smallest crack can become a complex feature. That's why underground structures rely on multiple layers of support instead of a single protective layer. The exterior surfaces are perfectly insulated, protected by thin layers. Every joint, every crevice, every inch is designed with precision. Floors are particularly vulnerable because they withstand solar movement during heavy weather and construction. Reinforcing these areas greatly improves the long-term durability of the bunker. As waterproof membranes are installed, the shelter will get closer to the maximum ground level. These protective layers add continuous layers that prevent moisture from leaking out of the building.
Once buried beneath the soil, These membranes will quietly perform their job year after year without ever being seen again. It's one of those invisible construction details that often determines whether a bunker lasts for decades or develops problems within only a few years. Next comes thermal insulation. Although the surrounding Earth already provides natural temperature stability, additional insulation dramatically improves comfort inside the bunker. By reducing heat transfer through the structure, less energy is needed to maintain comfortable conditions during both winter and summer. The combination of insulated masonry and exterior insulation creates a highly efficient underground environment. Construction now shifts towards drainage. Many people assume waterproofing alone is enough to keep underground structures dry. In reality, proper drainage is equally important. Instead of allowing water to build pressure against the bunker walls, drainage systems safely collect and redirect moisture away from the structure. Reducing hydrostatic pressure significantly extends the life of both the waterproof membrane and the structural walls. Every layer added to the bunker serves a specific engineering purpose. Some provide strength, others provide insulation, some prevent water intrusion. Together, they form a complete system where each component supports the others. This philosophy of layered protection is one of the defining characteristics of high-quality underground construction. With the protective systems complete, attention turns to one of the most visually dramatic stages of the project: backfilling. The heavy machinery returns to the construction site. Large amounts of soil are slowly moved back around the bunker. This process may appear straightforward, but it must be done carefully. Placing too much material too quickly against one side could create uneven pressure before the structure is fully supported. Instead, soil is added gradually in controlled layers. Each layer is spread evenly before additional material is placed. This balanced approach protects both the waterproofing system and the structural integrity of the bunker. As the excavation slowly disappears, the building begins blending back into the landscape. Only a short time ago, there was a massive construction pit. Now the earth is reclaiming the site. The bunker becomes increasingly invisible. This natural concealment is one of the greatest advantages of underground architecture. Protected beneath the surface, the structure remains sheltered from extreme weather, strong winds, and even many external environmental changes. Its presence becomes almost impossible to notice from a distance. Once backfilling is complete, final grading begins. The surrounding ground is carefully shaped to direct rainwater away from the entrance and prevent pooling around the structure. Even slight slopes play an important role in protecting underground buildings over the long term. Proper surface drainage reduces unnecessary stress on waterproofing systems, while helping preserve the surrounding landscape. Now the builder turns attention toward the entrance. Unlike the hidden portions of the bunker, this area will remain visible and accessible every day. Strong construction, precise alignment, and weather-resistant materials ensure the entrance remains both functional and secure. This single opening serves as the connection between the protected underground environment and the outside world. Stepping inside now reveals just how much the project has evolved. The thick, insulated walls create a sense of strength and permanence. The enclosed ceiling gives the interior a comfortable feeling despite being surrounded by earth. The carefully constructed space feels surprisingly warm, quiet, and secure. One of the most remarkable characteristics of underground shelters is their natural acoustic isolation. The surrounding soil absorbs outside noise, creating an environment that feels calm even during severe weather above ground. Combined with stable temperatures and solid construction, the bunker becomes much more than a simple storage space. It becomes a durable shelter designed for year-round use. Looking back over the entire project, it's remarkable how much has been accomplished.
What started as an empty excavation gradually became a carefully engineered underground structure. Every stage depended on the one before it. A solid foundation supported accurate walls. The walls carried the roof. The roof protected the interior. Waterproofing preserved the structure. Drainage protected the waterproofing. Finally, the surrounding earth completed the bunker by providing insulation, concealment, and natural environmental protection. No single step could have been skipped. Each phase required patience, planning, and precision. This project demonstrates that successful construction isn't about rushing towards the finished result. It's about making hundreds of small, correct decisions along the way. Every carefully measured block, every level check, every waterproof layer, every load of soil contributes to a structure capable of standing strong for decades. Underground bunkers have fascinated builders for generations because they combine engineering with nature in a unique way. Rather than finding gas in the